Hello everybody, Miss Collin here, and today we're going to be talking about normal distributions and bell-shaped um, curved graphs. Okay, so the biggest thing here starting off is just to be able to know the parts of a normal distribution and a bell curve. So here is a great little photo I have here that kind of explains the parts of a bell curve. Okay, so in the middle here, as you see this purple line, this is your mean. Okay, so your mean is in the middle and all your data goes around it. Now, this is if you have a normal distribution. We'll talk about having skewness in a second, but if you have a symmetrical distribution where your mean is in the middle and your data falls around it, this is how we would organize that data. We can look at it and read information from that. Okay, so the important stuff here is the percentages and the standard deviations. Okay, so you should know what a standard deviation is based upon lesson 11.7. If you don't, make sure you go back and watch that first. But how this is divided up is we have our mean here, and then we have one standard deviation, or if you want to have it as, this one standard deviation, -1 away, and one standard deviation away this way. And then it goes 2 standard deviations, 3 standard deviations, -2, -3. Okay, now majority of our data is in the first part of this bell curve here. We have 34% over here and 34% over here. Or, as it says, 68% of our data falls within one standard deviation. So this is 68% of our data here, just from this standard deviation to the first standard deviation. Okay, then after that, our in between our first and second deviation, we have 13.5% of our data. So we have 13.5% over here and 13.5% over here. So if we take everything from our second standard deviation all the way to our other second standard deviation, we have a total, this is 95% of our data, because 13.5 plus 34 plus 34 plus 13.5, that's 95% of our data right there, guys. So we have, a lot of times we'll use this for, I'll set this up when I do a test. And if I have most of my data within here, 95% of my data is around my mean, that's great, okay? Then out here in our third standard deviation is 2.35% and 2.35%. It's a small amount, but we go from here to here. That's 99.7% of our data. Okay, so 99.7% of our data falls within 3 standard deviations. That's almost 100. We have this like little 0.1 over here and this little 0.1 over here. Okay, of, sometimes outliers are out here, etc. Okay, so this is symmetric. Symmetric means if I took this and I folded it in half, they would lay on top of each other, and as you can see, they kind of mirror each other, the data. Okay, so that's the base of it. Now, when we come down here, we're going to talk a little bit about skewness. Okay, there are different types of curve. Now, I want you guys to exit this out because I don't want you to get confused about skew to the left and skew to the right. So we're just going to kind of do that. Okay, now this is what a normal bell curve should look like. But statisticians, when they're doing this, sometimes they get a curve that looks like this green one here or a curve that looks like this blue one here. That means their data is skewed. Okay, normally you do not want your data to be skewed. How does it get skewed? It gets skewed by outliers or a higher mean than a median, etc. Okay, so it's when our data is not evenly distributed. All right, now this is called a positive skewness, okay, and a negative skewness. Or what you'll see more, especially in the SAT, is your data being left skewed. That means that my tail, I call this the tail here, is on the left, okay, or right skewed. That means my tail is on the right. Okay, so this tells us a little bit about our data. It tells us that, okay, we have some high values over here that are skewing our data. Okay, we saw this before in our other lessons when we had like that 190 outlier, right? That'll skew our mean, that'll skew our data. Whereas in a left skewed, that's when we have like someone who got a 27% on your, like the quiz that we took, like someone who got like a 27% on the quiz, and that totally skewed my data to the left. Okay, it has those low values that are skewing it. Okay, so it's important to be able to identify if a graph is skewed to the left, skewed to the right, or it's a normal distribution, it's symmetrical. Okay. All right, we're going to come back to the calculator. And right now, I would like you to go to the next page. And we are going to talk about how to analyze normal curves, but first I want to talk about how to draw them. Okay, how are we going to draw normal curves? So I already have this in here for you. Sometimes when you draw it by hand, it does not always come out this pretty. But what you want to start with is, once again, we're just going to kind of label our graph. So we're going to show that, you know, going from here to here, these are little markers that show us some stuff here. So I'm just going to kind of mark that up. Okay, so you don't have to mark it up like this always, but sometimes it just helps, okay? So if you were to draw one, I would not expect you to mark it up, but I always do, just to kind of remind myself of what I'm doing. So here's your mean. Here's one standard deviation, and here's -1 standard deviation, 2 standard deviations away, 3 standard deviations away, -2 standard deviations away, and -3 standard deviations away. Okay, so this is kind of like the general graph here. Now, you're going to be given some information, okay? So to even draw a normal curve, you need a mean. Now, normally we've been talking about X bar, or something that's called a sample mean. Okay, but when we're dealing with normal distributions, we're going to be given something called mu. Okay, mu is our population mean. Okay, we gather this data from a population, not a sample size. So that's normally what our distribution, our normal distribution is around, okay? It's our population mean. Okay, so you're going to see this mu a lot. Not you. I know you think maybe I'm just losing my mind, quarantined, and not speaking correctly. But no, it's mu. Like it looks like an M and then a U, right? Okay, so that is really what goes here, our mu. All right, now, you're going to be given some information here. So let's say I give you a problem and I say, okay, your mu, your mean is 50 and you have a standard deviation of 6. All right, you can set up a bell curve with only that information. All right, we can put our 50 down here, and then we're going to add 6 for our standard deviation over here, and we're going to subtract 6 for our lower standard deviation over here. Okay, so you're just going to kind of follow that pattern. So this will be, let's make this a little bit smaller, and maybe in red. Okay, we're going to subtract 6, add 6. So then this will be 56. Okay, this will be 62 and 68. This will be 44, 38, and 32. Okay, and what does this tell us? Why do we set this up? Well, this tells us that most of our data is at this 50 mark, depending upon what we're talking about. And eventually we're going to be asked questions like, where does 68% of your data fall? Well, 68% of my data, this is 34, this is 34. So 68% of my data is between 44 and 56. Okay. This is 13.5, and this is 13.5, which means that 68%, 95% of my data falls from 38 to 62. And lastly, 99.7% of my data falls between 32 to 68 of whatever we're talking about here. Okay, so I'm actually going to work backwards here, and let's give it some context. Okay, so above here, they kind of give us an example here. So how to analyze this. So they say out of 100 packages of Jawbreakers, 68 packages contain 120 to 150 job breakers. Use normal distribution to estimate the average number of job breakers and the standard deviation of the sample. Okay, now this is just another picture here. So if we know that 68 out of 100, okay, we're talking about 68% of our data, right? So that means from here, from my -1 standard deviation to my 1 standard deviation, that's 68%. We can ignore these little 0.2s here. From here to here, I have 120 to 150 job breakers. So that gives me that information here, right? This is 120 and this is 150. Okay, now they want me to estimate the average. Well, if I want to find the value in between these two, I have to add them and then divide by 2. So 270 divided by 2 is 135. Okay, which means my mu, or my mean, is 135. And my standard deviation, how do I find that? Sorry, I'm doing like a theta. It should be more of like that more. My standard deviation can be found, well, how much am I increasing? I'm adding 15 here, and I'm subtracting 15 here, which means my standard deviation is 15. Okay, I would then be able to fill out the rest of this bell curve if they asked me to. But right here, they just asked me to find the standard deviation and the mean. Okay, so this is how we're going to use normal curves. All right, let's go backwards again, previous page here. And we're going to come down here to, what about on our calculator, Miss Cullen? How are we going to do this on our calculator? Well, first, let me give you an example problem. I'm going to type it up, and then you can write it down. Okay, so here's a problem / example that I would like you to copy down. So battery lifetime is normally distributed for large samples. The mean lifetime is 500 days. Okay, so you may want to come in here and mean lifetime. Let's see, that's my mu. And the standard deviation is 61 days. So that's my standard deviation. To the nearest percents, what percent of batteries have lifetimes longer than 561 days? Okay, so this is going to be called our lower bound and our upper bound. You're going to use this for normal distribution as well. Okay, so our lower bound here is 561, right? We want greater than 561. Okay, a number greater than 561. Okay, now, real quick, when we're using our calculator here, we're going to use it, this we're not really going to use to draw the actual normal distribution for us, because we really only do that when we're looking at z-scores and we're figuring out shading, which I will do in the next video. Okay, so it is used for z-tests in 11.7/11.10 review, but right now I'm just going to talk about normal CDF. Okay, normal CDF. So, how does that work? Well, first off, what might help you, I know what always helps me, is I draw my normal distribution first. Okay, so I say, okay, well, let's think about this here. I have, hey, that was pretty good, huh? Okay, I have my mean here at 500. Okay, and I am trying to, I know that my next standard deviation here will be at 561 and we'll be at 439. And then if I keep going here, oh, that's bad. Let me fix this. Okay, this is at 561. And then my next one. Okay, so after 561, make this a little neater here for us. And you're getting this all copied down. All right, so how I'm finding this is I'm just adding 61 each time. So this will be 622 once I get to my second standard deviation. Remember, this is my first, this is my mean, this is my -1, -2. Okay, we always want to label about 3 standard deviations. So this will be 683. This will be 439. I'm just subtracting 61 now. And this will be 317. Okay, so I added 61 and subtracted to find these parts. Okay, now they're asking me what percent to the nearest percent of batteries last longer than 561 days with this mean and this data. Well, guys, I can already kind of estimate this without my calculator because I have 561 here right at my first standard deviation, right? So I know, okay, well, they want to know how much is from here to more, right? Well, I already kind of know how this is broken up, right? I know that this is 34%. Okay, I know that this is 13.5%. This is about 2.35%, and this is about 0.1%. So if I add up 13.5 plus 2.35 plus 0.1, I get about what? 15.95%. Okay, so that's about an estimation to the nearest percent. Okay, so maybe 16%. Okay, around there. Right, but if I want a more accurate set of data, here's what I can do. All right, now first I'm going to kind of give you the steps. Okay, so on your calculator, the first thing you're going to do is just go to a blank screen. Okay, then you're going to click on menu. Okay, and there's actually 2 different ways that you can get here. I'm going to come here to my Inspire, and I'm going to go to menu. I'm going to go to just add calculator. Okay, menu stats, or you can do probability, either way. Okay, so if you go to probability, you can go to distributions, or if you go to stats, you can also go to distribution. So it doesn't really matter which one. What does matter is that every time you do this, you need to come to normal CDF. Not normal PDF, normal CDF. Okay, when you click on this, they're going to ask you for a lower bound and an upper bound. Then they're going to ask you for your mu and your standard deviation. Our mu is easy. We already know that that's 500. Our standard deviation here, we know is 61. Okay, lower bound and upper bound. Well, our lower bound here is 561. We want data greater than 561. For your upper bound, you kind of have to estimate. I'm just going to put in 1,000. Now you can put in a bigger number. We don't know our upper bound. We don't know what our data goes to. So we're just going to kind of stop there. Okay, then we're going to press OK. And here they give me this. Now, you can take this and multiply by 100 to get 15.86%, or just know that that is a percentage. And we can come back here and we have 15.8% as our answer. Okay. 15.87%. Pretty close to this, right? So this is kind of what I set up to kind of estimate, and then I check it with my calculator. So here you go to menu. My third step is stats, then normal or distribution, and then normal PDF, normal CDF. Okay, put in your upper bound, lower bound, and you're good to go. Right, that's all for this video. Stay tuned for more. Have a great day.